Temperature sounds simple. You look at a number and think that is the temperature. But it is not that simple. The air near the ground can be warm. Just a few meters higher, it can be cooler. Cities trap heat. Grass cools faster than concrete. Water warms slowly and cools slowly. Shade changes temperature. Wind changes temperature. Moisture changes how warm air feels. If you place a thermometer in the wrong spot, you get the wrong reading. And small errors matter. Temperature controls wind. It controls cloud formation. It decides whether rain turns into snow. So if temperature is measured poorly, the entire forecast can be wrong. That is why meteorologists follow strict rules when measuring it. Most official temperature readings come from ground weather stations. But these stations are carefully designed. The thermometer is not left in the open sun. It is placed inside a white shelter. This shelter blocks direct sunlight but allows air to flow freely. It is raised above the ground, at a standard height, not too low, not too high. Why? Because the ground heats up quickly during the day. If the thermometer touches that heat, the reading becomes false. By placing thermometers at the same height everywhere, meteorologists can compare temperatures from different cities and countries. Consistency creates accuracy, and accuracy creates better forecasts. Temperature does not stay the same as you move upward. In most cases, air becomes cooler as you go higher. This change affects everything. If warm air rises easily, clouds can grow. If cooler air traps warm air below, weather may stay calm. Meteorologists need to know how temperature changes above the ground. Surface readings are not enough. The sky has layers. Each layer behaves differently. To predict storms and wind patterns, scientists must measure temperature through the entire column of air, not just at your backyard level. One of the most important tools for measuring temperature above the ground is the weather balloon. Twice a day, balloons are released around the world. As they rise, they carry a small instrument box. This device measures temperature at different heights. It also measures pressure and moisture. As the balloon climbs higher, it sends this data back to the ground in real time. Eventually, the balloon bursts high in the atmosphere. But before that happens, it creates a detailed temperature profile from the surface to very high altitudes. This information helps predict storms, wind patterns, and sudden temperature shifts. Commercial airplanes also help measure temperature. As planes climb and descend, their onboard sensors record air temperature. Even while cruising at high altitude, they collect data. These measurements are sent to forecasting systems. Aircraft fill in gaps between balloon launches. They provide thousands of extra data points every day. This helps meteorologists see temperature patterns more clearly across large regions. When you fly, the plane is not just carrying passengers. It is also collecting information that helps improve weather forecasts. Satellites do not carry thermometers in the air. Instead, they measure heat energy coming from the Earth and the atmosphere. Everything gives off heat: land, water, clouds, air. Satellites detect this heat, using special sensors. By studying how much heat is being released, scientists can estimate temperature across large areas. This is especially useful over oceans and remote places where ground stations are limited. Satellite measurements are not as direct as a thermometer, but they provide global coverage that would otherwise be impossible. Even small temperature errors can cause big forecast mistakes. If the atmosphere is just slightly warmer than expected, a storm may become stronger. If it is slightly colder, rain may turn into snow. That is why temperature data is constantly checked. Sensors are tested, readings are compared, outliers are removed, different systems are cross-checked against one another. Accuracy is not left to chance. It is maintained through constant monitoring and correction. Temperature is one of the most important parts of weather forecasting. It shapes storms, it drives wind, it influences precipitation. From ground stations to balloons to aircraft to satellites, temperature is measured in many ways. All of that data flows into forecasting models. But even with perfect temperature readings, there is still uncertainty. That is why forecasts often say there is a certain chance of rain. In the next episode, we will explain what that percentage really means. Thanks for watching. If you enjoyed this video, please subscribe to the channel. You can also follow us on the platforms on screen for more simple, easy to understand videos about the technology behind everyday products and systems.